and welcome to this edition of Silicon Grapevine. I'm Nitin Dahad with the Times, and today I've got a guest from the UK for a change, Haydn Povey. He's, I would call, a kind of a serial entrepreneur, but also I think he's one of the key guys behind the Arm Cortex-M processor, which most of you use in mobile phones. But also, I think he sort of evolved into sort of developing a lot of the IoT security type activity, and through Secure Things, which he sold to IAR. So he's got quite a good background in mobile and security and IoT. Hello, Haydn.
Hi, Nitin. Thanks for having me.
Great. So, Haydn, thanks for coming on the show. And we seem to meet mostly at security conferences or conferences in London. But today we're meeting online. So tell us a little bit about you. Yeah, how did you get into this business?
That's an interesting one, and there's plenty of grey hair as well. Some of that is going as well these days. It's a really interesting question. I was presenting to some other people recently about history and security and safety. And it occurred to me that actually my formative part of this was Piper Alpha. And for those people who aren't aware, this was a big oil rig in the North Sea which exploded. 130 people died, many of them never found, actually. And at the time, I was actually working for a control company and doing actuator control for oil pipelines. And because we had supplied the actuators to Piper Alpha, of course, we were part of the investigation. And it really has always stuck in my mind over the long term over the need for safety and security. Because of that, when things go wrong in cyber-physical systems, people's lives are very much affected. So thankfully, we had nothing to do with the accident. There was a piece of pipework which had been removed from maintenance, and then the LNG had been pushed back through that accidentally. But it actually reinforces everything I've done ever since, which is around control, the electronics, the safety of systems, the microcontrollers at Arm. All of these things have that cyber-physical domain, and when something goes wrong, it can go wrong catastrophically.
Yeah. But just you were you with this control company? Were you an electronic engineer, or were you doing something? I mean, tell us the story, Haydn's story.
It was my first electronics job. So I was doing some very basic control systems, good old 4 to 20 milliamps.
Okay.
So when you actually had to run a wire to everything and bring it back, and there was timing in there. So when you're moving an actuator with a big oil pipeline running underneath, you have to do it in a phased way, in effect PWMing the control so that it doesn't overburden. So I was doing that. It was actually a summer job while I was at university. And then I came out of there and went into National Instruments again, my cyber physical knowledge and that passion for, okay, we have to have things which work, which are safe, which are better managed. Actually worked very well with the transition into National Instruments here in the UK, or NI,
right,
as they are now.
And is that sort of then when, what was the story when you sort of fell into ARM? Or I remember there's a really interesting story that you and I were talking, I think, with Clive Watts and a couple of other people recently.
Yeah, absolutely. So I spent, actually probably about 10 years with NI, both here in the UK and in Austin, Texas. And that was a great formative time in my career, and then had moved back to the UK, was doing some work with another company. And at that point, Arm was looking to start their microcontroller business group, and actually headhunted me to come into the organization,
right,
to lead the Cortex-Ms. And again, Arm, great company, great people. but really didn't have that cyber physical, real world connectivity. Everything was in mobile phones. That's great. The early ARMs, the 7 TDMI, great processors, but realistically, they wanted people with real world experience of connecting to things. Before we called them things, when we still called them embedded.
Yeah.
And that worked out very well. And I came in, I helped define.
What year was that?
Oh, wow. That is a very good question. It is
mid-2000s.
Yeah, it is. It's mid-2000s.
I think that's when we met. I think we met on the steps of an aeroplane going to Nuremberg.
That's right. That's right. Myself and one of my colleagues, we were talking about technology. We were talking about people. Warren East, who was the CEO at the time, and yes, I think you were sat behind earwigging, as all good journalists do.
I wasn't a journalist that time, though. Yeah.
But yes, and again, the evolution and the way that we went out and we managed to impact industry has been a fantastic story and a great success for ARM.
So, like that, you got into ARM, the mid-2000s. You were headhunted to develop that microcontroller. Tell us how long that took, and what sort of team effort that was.
That was it was a very interesting project. It took probably another 2 to 2.5 years to really bring the product to market, and there was a number of aspects to that which are interesting stories. The first one being that actually the engineering team for the what became the Cortex-M3 was largely dispersed at times to ship other products. And it's often true that success has many fathers and defeat is an orphan. But the reality is there was a lot of people questioning why we were doing microcontrollers inside of ARM and not really behind the program. I was very lucky. I had an architect out in Walnut Creek, Paul Kimmelman, unfortunately, who's passed, and Ian Field, who worked with him. They were really fantastic visionaries working with me on that. My engineering lead on it was Gary Campbell, who's now VP of Central Engineering at ARM, and we had a great passion there. And then the only other person who I think really bought into it was Tudor Brown, the president of the company, and that he gave us the air cover to go and continue the project, and we're really glad that we did. It was interesting. I shared an office with John Goodacre, who is the father of MP Core, and we were the Skunk Works office inside of the ARM building.
Was John into his motorbikes even then? I mean, he goes on his motorbike everywhere.
Absolutely. So we were at the end of the corridor. We didn't have many visitors at that point, but I think we held the vision, we held the keys very much for the future, and I think we've seen embedded become really strong for ARM, and we've seen MP Core and Big Little and those sort of technologies also become the foundations of the industry.
Yeah, that's a good achievement. So then, what happened after that? So you because I think at some point sort of you branched off and then actually sort of started up Secure Things directly. But tell us.
What was that journey? Well, as I often say, no good deed goes unpunished.
Yeah.
So we were very successful with the embedded cores. The Cortex-M family really caught fire. We worked with the ecosystem to enable that. Companies like IAR, Green Hills, and others really came on board. And we built great licensing relationships with ST, Luminary, Broadcom, and others. But eventually, as all things do, things changed. And actually, Graham Budd, who was Chief Operations Officer at ARM, came back from a trip to Japan where there had been some tough conversations with a customer around some digital rights management implementation using the company's trust zone technology,
Mm.
and it wasn't going right, as
Yeah.
these things do. And I clearly remember he sat on the corner of my desk and he said, "Haydn, you now own security technologies. Congratulations." And that was my introduction to security.
Right.
So it was then a very fast learning curve of understanding really the impacts of security on an SoC and on a system and how that needed to be evolved.
Mm.
So I worked on that. I worked with some key partners, G&D, Executive Endeavor, Gemalto, and others.
Yeah.
And our key licensee for security technologies, TI, to really start to put together a solid foundation for security,
Right.
what became the TEE, Trusted Execution Environment,
That's right.
and bringing that to bear. And that underpins Apple Pay, Samsung Knox, really all the modern security that you see in the phone, in the tablets, and in modern PCs as well.
That's right. Yeah. So then, how did Secure Things materialize?
One of the things which happened there is we actually span out a company, a three-way between Arm, Trustonic.
Oh,
So
yes.
the company was Trustonic, so it was
Mm.
Arm, G&D, and Gemalto. Arm 40%, the others 30% each. And I shepherded that through all of the antitrust requirements with China in the EU. Unfortunately, at that point, they didn't want me to help run that organization, which probably was a very good decision in the end.
Yeah.
But I looked at it and I looked at what those guys were doing around mobile and thought, well, actually, security and embedded is the next big area. And of course, that intersection of my passions.
Mm.
And so I said, okay, well, I will go and do my own startup. I'd wanted to do one previously and decided it was the right time for me to take some money that I'd got in the shares from Arm and invest it. And
Was that the first IPO? Yeah, it was actually. No, actually, no. It was afterwards.
It was
Yeah.
it was after it. It was
That's
after
right. Yeah. Yeah.
the first IPO, but
Yeah.
again had accrued enough shares and
Mm.
had those vested, so I could go and do that, and that was fantastic. It was a little scary,
Yeah.
but very quickly, thankfully, again because of my connections, worked with people like Renesas on their Synergy platform, what is now really evolved into the RA
Yes.
processor line to help them understand their security needs and the market needs. So a bit of consultancy, a bit of product, and we very rapidly actually carved out a niche around security for embedded systems.
Right.
At which point we'd taken some strategic investment, and then IAR, after about 18 to 24 months of the company, came in and acquired us
Mm.
to add into their embedded tools suite.
Yeah, I remember being a little bit of part of that journey, working with you for a year or so.
Absolutely,
Yeah.
absolutely. Some great
Yeah. Yeah.
marketing materials.
Yeah,
Absolutely.
but so tell us a little bit about what you're up to now, because I think you do some. One of the things when anybody talks to you is they understand you're Mr. Security. You have so much to say about security, and whenever I've spoken to you, I've taken notes and notes and notes, and like my books fill up very quickly. My notebooks fill up very quickly, but that sort of has put you in a good sort of position to be. I would say evangelist, but yeah, that thought leader. But also, you're doing a lot of public good work. So tell us a
Yeah.
little bit about that.
So yes, as many people in the industry do, I'm wearing multiple hats all the time. So I recently took a step back from IAR on a daily basis, but still do some consultancy for them and for some other people. So I was recently in Spain with a large OEM of systems on modules talking to them about the legislation which has come through in the UK, the PSTI, which is already in place and impacts in April of next year.
Just PSTI stands for people who don't know.
It stands for the Product Security and Telecoms Infrastructure Bill,
Okay.
and it defines 3 pieces of hygiene which you have to sell any consumer electronics in the UK
Okay.
around identity, disclosure,
Got it.
and
Okay.
and updates,
Okay.
and that has the same penalties as GDPR. So anybody who sells electronics into the UK and ultimately over time into Europe needs to be aware of that. Unfortunately, it's not always the case.
Mm.
So I'm still doing that consultancy, but I also continue to do good works with the IoT Security Foundation, which is the leading non-governmental organization around IoT.
It's in its 10th year next year, I think, if I remember. And they had a very good conference on security, IoT security in the era of AI this year.
Absolutely. It was a fantastic conference, and kudos to everybody who was involved in that. Great speakers, great keynotes, and great organization. And the IoTSF is growing. We now have chapters in India and in the US. And
Yes.
while it started in the UK, it really has gone international. We have the best practices which underpin things like the ETSI, EN 303645 rules, the Australian, Singapore, Japanese, and other frameworks.
So yeah, the few years that I've been writing with the Times, I think one of the things I've noticed is some of the reports and the documents produced by IOTSF have been sort of used as good practice and used in sort of in the US and Asia and Europe as well.
It really has led the way, and I'd encourage anybody who's watching this to be part of the foundation. And if nothing else, go and download some of the materials. They're freely
Yeah.
available online. Over 60,000 downloads of the best practices has already happened. So, and that is going well and evolving. But I'm also involved in another area of security, which is more than just IoT. It really is general compute.
Yeah.
And this is something which has been led by the UK and US governments over the last 10 years, which is digital security by design. The UK Department of Science, Innovation, Technology, DCIT, have really been leading on that. There's around £100 million worth of investment, which has gone into that, and other monies around that as well. And
just a side note on that, I mean, that was being led, well, the figurehead was John Goodacre again.
The same people turn up.
And we've seen some of the results of that with some of the Morello boards coming out with companies like Codosip and also Low Risk putting stuff out.
Absolutely. So we are starting to see the fruits of that after 10 years. The concept being, if we didn't have computers already, how would we change things? How would we implement things to avoid memory allocation issues? If you look at attacks, 70% of attacks are around memory allocation issues.
And this was highlighted in the 1970s, so it's nothing new.
It's not. And it's just really a case of, okay, if we could reset the clock, what would we do to manage that? And okay, that thinking then evolved and went, okay, well, we can't do that completely, but what are the changes that we need to make? And this has developed something called Cherry, or Capabilities Hardware Extensions.
One of your ex-colleagues told me it was a fruit the other day.
It is a fruit. I mean, I would warn people, if they search for Cherry online, they may come up with some slightly more risque websites. So search with caution, as always.
Yeah.
But the goal here is to bring through things like compartmentalization, so better concepts for separation, isolation, reuse of code, pointer contextualization, and it changes the way that the world works. We are now seeing how we can do that. So Arm did a test chip, Morello, as you say, which integrated Cherry into their Neoverse device. We are seeing other companies start to bring that to market. And in fact, one of my other hats at the moment is that through a company called SCI Semiconductor.
Yeah, this is your new startup.
Yes, yeah, absolutely. I've got to give that a pitch. Absolutely.
And the SCI stands for what?
Secure Compute Institute.
Yes.
So the goal is that we do want to be, very much at the center of secure compute or secured compute. You're never going to secure something 100%, but we can make it a damn sight better than it is today. Some of that will be through IP, some of that will be through documentation and leadership and training, and some of that will be through silicon products. And we certainly want to bring through a range of low-end microprocessors where we can very rapidly integrate the software stack and tools which actually make this useful. So real-time operating systems and things along those lines, and make it available to the industry. Morello, the Arm solution, fantastic, but it's a very high-end device. It's going to take us years to get Linux and the full LAMP stack ported onto that sort of platform.
So I'm sure we'll hear more about that. But in terms of what are you seeing as the bigger trends in industry? I mean, security is a thing you live for, but yeah, cybersecurity and cyber physical systems. What's the big trends you're seeing? Because you're going around talking to lots of, and these are not small companies, large companies, and are they doing what you were preaching many years ago, or is it still one of those things? And I know I hear quite mixed messages about what's going on.
It's a mix. I think everybody inherently wants to do the right thing. Nobody wants to purposefully do the wrong thing. I think the meta trends, which I see the most important one, is a return to really edge computing, call it embedded 3.0, where the AI processing, the inferencing, and the control is done at the edge. And that's driving a new revolution in compute performance and in capability back into the devices. So, having cloud computing is fantastic, but you don't want to ship everybody's private data across the network.
Yeah.
It used to be said that, data was the new oil. I really think data is the new asbestos. You have to really manage it with care.
Yeah.
And there are real risks in handling people's data. Let's keep it in their homes, keep it on premise from a commercial perspective. And the fact that the networks, even with 5G and 6G around the corner already, we're never going to have sufficient bandwidth. We're never going to have the latency resolution that we need. 5G helps with some of that in terms of some of its implementation capabilities. But the reality is you want to keep the raw data as close to the decision point as possible and then just set the controls. Obviously, to do that, AI comes in. And then there are these other aspects, as we saw at the IoTSF conference this week. Okay, how do I then manage AI in an embedded system? How do I ensure that the decisions it's making are based on models which are provable, which are validatable, which when they're tested in court, which they will be, somebody can say, well, here's all the data sets which I've trained it on, therefore the inputs give these inferences and outputs. There are lots of challenges around that because AI is very dependent on the data it's trained on. It's very dependent on the data that is presented to it, but it's also very dependent on the platform that you're executing it on. And if you change that, even midlife performance changes, or as the processors wear, or as system implementations happen, you're going to get different answers.
Yeah.
And again, back to the start, if that is the fact that there's an anomaly in my heating system, a couple of degrees, I can go and adjust the thermostat. But if it's in a critical infrastructure system, people can die.
Yeah.
And so we have to be very, very careful around that.
So this is like where people have been talking about AI being scary, dangerous. I think people don't see the real things. They're just thinking about the robots and the artificial intelligence. But there's more deeper stuff than that.
There really is. I mean, and it's going to be everywhere, and it's going to surround us. I think Microsoft's concept of a co-pilot
Yeah.
is the best one, where there's still a human in control and a human in the loop, because there's a very strong law of unintended consequences. And so as we look at how these things are implemented, we have to make sure that we don't completely take our hands off the steering wheel.
All right. Let's we have got a lot of understanding now of your sort of position in that. Tell us a little bit about you, Haydn. What gets you excited apart from security?
Well, I think I'm a little over the map. So I do some charity work with a think tank in the UK, based in the West Midlands, which is Birmingham and the central area of the UK. Kind of the area squeezed between London and Manchester, which people travel through quickly on the train or very slowly through in the car. And so I've been working with those guys around digital enterprise and how we help SMEs and larger companies.
SMEs are small and medium-sized enterprises.
That's right. And how we take a lot of these innovations, which we live and breathe every day, and how we actually start to apply those into the regions of the UK. So that's a bit of a passion there. So working with groups supporting things like better housing. How do we get to net zero with the housing stock that we have? How technology can help with that? How transportation systems can be more improved? I actually live near Cambridge, and I am very used to bad transportation systems and traffic jams. And there are solutions, but we have to embrace them.
Intelligent transport systems and solutions. We need all of that.
We certainly do. So, and apart from that, I'm very lucky. I own a small farm as well in Cambridgeshire. So, keeping that in order, managing some of the animals and those sort of things, that gets me out of bed pretty early in the morning.
What kind of animals?
Mostly beef herd, managing them, and some other animals as well.
Cattle. That kind of interesting. It sounds exciting. Tell me, one of the sort of things I sort of ask everybody who comes on this show is, what would you give as advice to young Haydn, or somebody who wants to be like you, as Banu says? What would you tell young Haydn, looking back on your career and what you've done? And I think one thing that sort of strikes me about you is you're living that holistic, sort of, you understand the technology, but you're also trying to put it into play into real life. And I think that's quite interesting.
I think there's two pieces of advice I've really learned. The first one is to go for it. Being a Brit, we're slightly reserved, and we're taught to get a good job with a big company and to stick with that. The reality is, I wish that I had. I love my time at Arm. I wish that I had done the startups earlier. And you learn a lot through failure. That should never be a problem. And you can go again. Obviously, we all have mortgages to pay and things along those lines. But I think find a passion, live that passion, and the opportunities will actually come out of that passion. And that's exactly what happened to me with Secure Things and so on.
Yeah.
I think the other piece, which is actually how I now hire people and how I manage people around me, is don't tell people what they're bad at.
Yeah.
Anybody can do that. Find what people are naturally good at and help them become great. There's a great book, Strength Finder, which I was introduced to probably about 20 years ago. And it's all about finding what you're good at, what you're passionate about, and reinforcing that. We cannot all be good at everything. We're only good at a few things.
Right.
Let's become great and leverage those natural capabilities that we all have.
Well, Hayden, that's a really good thought. Well, thank you very much for coming on the show, and hope to see you again at the next conference or something somewhere.
Thank you very much, Nitin.